Okay, so we've been talking about angles, and the application of this is for triangles. And so we're specifically interested in triangles that have one right angle, okay, and the triangle will have one right angle and two acute angles. Okay, so remember, right angle means that it's 90 degrees. I denote that with a little square in the corner. And these two angles are less than 90 degrees. They are acute. And so we'll call this a right triangle. Any triangle that has one angle that is 90 degrees, we will call that a right triangle. And our standard notation is to label the right angle with a capital C. The other two angles, we will label those as A and B. And so the capital letters A, B, and C represent the three angles that make up the triangle. And then a triangle not only has three angles, of course, but it also has three sides, and those sides have different lengths, right? This side here, of course, is the longest side. The longest side will always be opposite of the right angle, and we call that the hypotenuse. So I'll write that here, the hypotenuse. We call this side the hypotenuse, and we will label the hypotenuse with a lowercase c. Okay, so I know it's hard to tell which is which here. This is capital C, that's lowercase. And then the other two sides, we will label those with the lowercase letter, the same letter that as the opposite angle. So angle A, this is the opposite side of angle A. We'll label that with a lowercase a. And for angle B, this is the opposite side of angle B. We will label that with a lowercase b. And so this leads us to a very important theorem that I won't necessarily prove for you here. But I'll just write it out. It's called the Pythagorean theorem, so I'll write that here, the Pythagorean theorem. Okay, Pythagorean theorem. And the Pythagorean theorem says that for any right triangle, it doesn't matter what the lengths of the sides are or what the angles are, as long as the triangle is right, one of the angles has to be a right angle, 90 degrees. For any right triangle, the length of the sides, the length of the hypotenuse squared, will be equal to the sum of the other two lengths of the other two sides squared. Okay, so the square of the hypotenuse is equal to the sum of the squares of the other two sides. And this is called the Pythagorean theorem, a very important theorem. Make sure that you remember this. And also with this theorem, we're not usually interested in what c squared is equal to. We usually want to know what c is equal to. And so to solve this for c, to get rid of the square, we will take the square root. Whatever we do to one side, we have to do to the other. So we'll take the square root of both sides. And the square root cancels the square. And we can say that the length of the hypotenuse will be equal to the square root of the sum of the squares of the other two sides. And with the Pythagorean theorem, I'm going to write it again. Sometimes we're not always interested in the length of the hypotenuse. We might be interested in the length of side A or the length of side B. So for example, I can solve this for A by subtracting b squared from both sides. And we will get c squared minus b squared is equal to a squared. Okay, and I'll write it out one more time. C squared equals a squared plus b squared. Maybe we're interested in b, and so I'll subtract a squared from both sides. And so we will get c squared minus a squared is equal to b squared. And so these are all forms of the same theorem, okay? Original Pythagorean theorem says c squared is equal to a squared plus b squared. Or we could say that a squared is equal to c squared minus b squared. Or we could say that b squared is equal to c squared minus a squared. And again, I could, just like I took the square root of both sides here to get c equals rather than c squared, we could take the square root of both sides of these equations, and I could say that a is equal to the square root of, how about c squared minus b squared, or that b is equal to the square root of c squared minus a squared. So I just took the square root of both sides, square root of both sides. And so c is equal to a squared plus b squared, take the square root, or a is equal to the square root of c squared minus b squared, or that b is equal to the square root of c squared minus a squared. Okay, and so again, this is the Pythagorean theorem.